for both hardware and software. So we want to know how we can use Raspberry Pi system to do something and to work on our project. And first of all, we have to understand Raspberry Pi is an electronic device. Okay, any computer system is it's an electronic device. So that means we have to deal with electronics. Okay, so that's why for this for today we want to help you to understand how can we interface electronics to Raspberry Pi. Okay, so first of all, actually, whenever you want to connect a circuit to any devices, first of all, you want to know how to analyze a circuit. Okay, so to analyze a circuit, actually there are several kind of devices. The most common device that you can use to analyze your device, the circuit, is called digital multimeter. I mean, nowadays we mostly use digital multimeter. Actually, when I was in college, we don't have we didn't have a digital multimeter at that time. We just used analog multimeter at that time. Okay, so but anyway, nowadays most of multimeters are digital multimeters. So it's so we just introduced the digital multimeters. So a digital multimeter actually usually we call it DMM. We use DMM to for digital multimeter. Is a invaluable tool for measuring the voltage, current, and resistance, capacitance of circuits. It's not only used for RPI circuits, as if it's designed for any kind of circuits, as long as you have all those electronics. Okay. And for this kind of device, it can be used to measure voltage, current, resistance, capacitance, all those inductance, all those basic electronics parameters that we can use to measure. So for example, if you have a circuit and you find that your circuit doesn't work correctly, you may you may think maybe the resistor is broken. So you can just use your multimeter DMM to measure the resistance or the voltage over the resistance to see whether it is still working correctly or not. If it's working not correctly, then you may consider to replace the resistor or replace another components. Okay, and these are some features for multimeter. Usually, digital multimeters they have the features of auto power off, auto range. So you don't need to select what is the range you want to, because when you try to measure the resistance of a resistor, usually you have to let the multimeter know the measuring range. But for digital, for analog, you have to specifically tell the multimeter your measuring range. But for digital, usually it's the multimeter automatically select the range. Okay. There are some other useful options. Okay. And actually for digital parameter, I don't know whether you saw that before. Let me show you an example. This is a digital multimeter. Okay, so you can see. Let me turn off the virtual. You see, this is a multimeter. It's a digital multimeter. So by using this digital multimeter, you can measure the voltage. So these are voltage, and then you can measure resistance, okay, and other things. So, for example, if you want to measure a voltage of a battery, I can show you. So this is a battery, and you can use this multimeter to measure the battery's voltage. Okay, so you can see. So the voltage is. I don't know how to. You see, this is showing the. Oh, yeah. So it's showing the voltage. Okay. Here. So the voltage is 1.59 something. So that's so you can see by using a multimeter, actually it's very easy for us to measure those important parameters. For example, like I've said before, if you have a circuit and you find that there is something wrong, you can use your multimeter to measure all those important parameters to see whether the circuit is correct or not. If the circuit is has something broken, then you can consider to replace the components. Okay. All right. So that's the multimeter. And another very important device for analyze circuit is called the oscilloscope. So oscilloscope actually is very important in circuit analysis. So usually oscilloscope actually typically only measure voltage, but enable you to see how the voltage changes. So it shows the the voltage change over times. And so let's see. This actually gives us an example. You can see this waves. They are the voltage changing waves. So it's the voltage change over time. So you can, I mean, by using a multimeter, you cannot see this. Using multimeter, you only see the voltage value. You don't see the voltage changing mode. In the over time. Okay. But by using a oscilloscope, you can understand, how does the voltage change over a period of time. Okay. So that's very important, especially for those, if you have a signal changing signal changing over a period of time. If you want to understand how does the circuit work, oscilloscope is a very important device you can use. Okay. And actually, usually oscilloscopes, they are pretty big device. And if you go to the lab, actually, you can see the oscilloscope. It's a big box. Usually, it's the same size, not the same, but similar size of a desktop computer. But there are some nowadays a lot of company, they design some alternative oscilloscopes. Actually, for example, I have this one. I can show you. This is a small oscilloscope. Actually, it's in one box. Actually, it's pretty small. What we do, this is the oscilloscope, box. Actually, we just insert this oscilloscope into a computer, and then you use the computer monitor to work as the display of the oscilloscope. And then you just this is very, it's called, it's very convenient because you can take this anywhere you go. So it's better than the big box in our classroom. So this kind of oscilloscope actually you can consider as a virtual oscilloscope. So it actually mainly supported by software. So you have to download their software, and their software will read in the signal from that box, and then display the signal on their software screen. Okay, so that's something nowadays we can use. But this kind of oscilloscope actually is very cheap compared to the big one in our lab room. It's cheap, but the problem is usually the bandwidth, the speed of the oscilloscope is limited. Okay, but it provides a very convenient option for us, and the most important convenience is we can take it anywhere because it's so small. All right, so after I introduced the two kind of circuit analysis devices, the DMM and also the oscilloscope, so let's go into those basic components, basic circuit principles. Okay, so for circuits, actually, usually there are two kinds of components. One components are called active components, and the other type of components are called passive components. So for active components, we have transistors, because this kind of components, they can adaptively control the flow of current. Okay. And for passive components, they cannot control the flow of current. Okay. So for active components, we have transistors, and for passive components, we have resistors, capacitors, and diodes. Okay, so we will. At this time, most of you, I believe, you don't know what are this, but we will see this later. Okay, so let's see. First of all, before we talk about those individual components, let's look at the basic law for electronic circuits. Okay, so for electrical circuits, the basic law is called Ohm's law. Okay, so before you understand what is Ohm's law, you have to understand what is current, what is voltage, and what is resistance. Okay, so think about current. Current means the flow of electrical charge. And you can imagine a river. The water flow creates a current, right? So that's the current. And voltage. Voltage means the difference in potential energy that forces electrical current to flow in the circuit. So also consider a river. So imagine why we have current. Because, we have the height difference, right? That height difference give us makes the water flow from high level to low level. Okay, because the gravity drags the water from high altitude to low altitude. So the altitude difference actually give us the force to create a current, a water current. Okay, so the voltage actually is the difference in potential energy that forces the electrical current to flow in the circuit. Okay, and current actually that's the electrical charge flow. Okay? And resistance. Think about, there are some big rocks in the river. It can block the water current, right? So resistance actually is the same thing. It's something that discourages the flow of charge of the current. Okay, so the relationship between these three parameters: voltage, we measure it in volts, and current, we measure in amps, and resistance, they are measured in ohms. Okay, so these three values, they have a very simple relationship. It's called Ohm's law. Okay, so Ohm's law, actually, this simple formula is Ohm's law. Okay, so you can see voltage equal to current times resistance. Okay, so current times resistance is the voltage. It's equal to voltage. Okay, so it's very simple. For example, if you know voltage, you know the resistance, you want to figure out what is the current, then you use I equal to, let me see. You use, yeah. So you use I equal to V over R. Okay. Let me try. Yeah. That's the problem. I cannot write on this computer. But anyway, so so like I've said, if you know the voltage and the resistance, then you have I will be equal to so let me okay. So you can use I equal to V over R. Okay, so I equal to V over R, because we already know the Ohm's law actually is V equal to I times R. So I, from this, we can see I equal to V over R, or R equal to V over I. Okay, so with all those variations of the Ohm's law, so if we have V and R, you can figure out the current. If you have the voltage and the current, you can figure out the resistance, right? And if you have the current and the resistance, you can calculate for the voltage. So that's the basic rule, but most important rule for electrical circuits. Okay. All right. So once we understand the Ohm's law, let's look at some examples. Okay. So this is one example. You can see this give us the voltage. So this is the voltage source, like a battery or your wall plug or something. You know, your power supply. You know, whenever you use an electrical device, you're supposed to have some kind of power supply, right? So that's the voltage generator. So you have to have a voltage, then you have current, and then your device can work. Okay, so this is the voltage. We can consider this as a battery, for example, and this is a resistor. Okay, so when you make a circuit, this is a circuit. Okay? A circuit must be a closed circuit to create current. Okay, so if the circuit is open, for example, if it's open here, then you cannot have current. Okay, so for this circuit, it's a loop, it's a closed loop. For this circuit, if you know the voltage, you see voltage is 5 volts, okay? And the current, we have a current is 100 milliamps. Then because you have the voltage and you have the current, then you can figure out the resistance, okay? So resistance, remember, resistance is equal to voltage over current. Okay, so in this case, voltage is 5 volts and current is 100 milliamps. So you have to use amps instead of milliamps. So you have to convert this from milliamps to amps. So 100 milliamps is equal to 0.1 amps, right? So you use voltage 5 volts over the current 0.1 amps, then you got 50 ohms for this resistor. So this resistor has a 50 ohms resistance, okay? And another example, by applying the Ohm's law. You see in here, instead of one resistor, we have two resistors, right? We have R1 and R2, okay? And the voltage is 5 volts. And you have to understand, this is the only power source for the whole circuit. That means on both of these two resistors, the voltage will be together, it will be 5 volts. So that means from this point to here, the voltage is totally 5 volts, okay? And if we have a current, because this is a serial circuit, or serial circuit, the current is equal to each other, is equal to equal everywhere. Okay? So you have a current I, so this I times R1 will be equal to VR1, and I times R2, it will be equal to VR2, and VR1, VR2 add together, it will be equal to 5 volts. Okay, so that's why we call this kind of circuit a voltage divider, because these two resistors, they divide the voltage of 5 volts into two parts. Okay, so how can we figure out the ratio of the voltage divider? We can do this. We know the total resistance is equal to R1 plus R2. In this case, we have R1 and R2 because they are connected in serial. So that's why we can directly add them together. If they are connected in another way, then we cannot directly add them together. Okay, so but if they are connected in serial, then we can add them together like this. And the voltage, total voltage is the supply voltage, which is 5 volts in the circuit. And these are the voltage for R1 and voltage for R2. Okay, so if we add these two values together, then we get the total voltage. So you can see the voltage divider rule can be generalized to the following. So you can see Vx is equal to V times R2 over R1 plus R1 plus R2. Okay, why is that? And what is Vx? Vx is this. This is the voltage. In fact, in this case, Vx is equal to VR2, right? So you can see Vx, and why is Vx equal to this? Let me show you. All right, so we already know that RT is equal to R1 plus R2, okay? And V is equal to VR1 plus VR2, okay? And we want to find out what is Vx. And we know Vx actually is equal to VR2, okay? And in fact, we already know that the current is V over, so VR2 it should be current I times R2, right? And the current is what? Current is V over RT times R2, okay? So you can see V over RT is what? RT is R1, so it's V over R1 plus R2 times R2. So it's equal to V times R2 over R1 plus R. Okay. So you can see this is why we say this circuit is a voltage divider. Because if you want to find out the voltage for R2, you just use R2 over the total resistance times the voltage supply. You don't need to figure out what is I, what is the current, okay? If you want to find out what is VR1, actually, you just use V times R1 over R1 plus R2. Okay, so that's the way that why we call this kind of circuit voltage divider, okay? So you can see this is the voltage division principle. And for voltage divider, usually we use potentiometer. Okay. Let me show you some this kind of components. These are this kind of components. They are called resistors. Okay, so you can see this is one single resistor. So it's very small, but it's kind of electrical circuit components. It's called resistor. And resistor actually provide resistance. Okay? So there are all kinds of resistors. So you can see if you can. I mean, it's very small. I don't know whether you can see it clearly, but they have color bands. Okay? So they have colors on the resistors, and those colors represent their values, because different resistors, they have different values, and so different resistors, they have different color band, so that represents their resistance. Okay? And anyway, you can use a digital multimeter to measure the resistance. Okay? And we do have potentiometers. So potentiometers, actually, they are also resistors. Okay? But this kind of resistors, these small resistors, they are fixed resistors. That means the resistance are fixed. Okay? But for potentiometer, this is also a kind of resistor. You see here, but there is a a switch here. So by turning this switch, actually we can adjust the potentiometer's resistance. So potentiometer, they are also resistors, but they are adjustable resistors. Okay, so that means by turning this switch, we can change the potential. I mean the resistance. Okay, so you can see that's why for this potentiometer, for the potentiometer, actually you have 3 legs here. Okay, so the 3 legs actually, this middle leg actually, if I go back to, oh yeah, so from this slide, actually you can see for the potentiometer, for resistor, you can see here, resistor you have only 2 legs. Okay, but for potentiometer you have 3 legs, 1, 2, 3. Okay, so these 3 legs actually, from this potentiometer you can see you have 3, 1, 2, 3. You have 3 legs. Okay, so the middle leg actually, by turning the switch here, you can move the location of the second leg. So that means you change the potentiometer's resistance. Okay, so that means you can adjust the the voltage division between this. Okay, so that means by adjusting the second leg, you can change the output from 0 volts all the way to 5 volts. Okay, so when the second leg is here at the bottom of the potentiometer, the output will be 0 volts, because the voltage over this wire actually we consider as 0. Okay, and if you move the leg to the top of the potentiometer, the output will be 5 volts. Okay, so that's the the meaning of voltage division. Okay. And this circuit actually is not a voltage division. It's actually a current division. Okay, so it divides current. So you can see for voltage division, the 2 resistors, they are connected in series. This is for voltage divider. Okay, but for current divider, these 2 resistors, they are connected in parallel. So in parallel, you see these 2 resistors, they are connected in parallel. When we say parallel, that means these 2 legs connected together and these 2 legs connected together. Okay. For serial connection, you see they have only one common leg. Okay, so for the other side, the other leg, they connect it to other parts. Okay, so that's all right. So for current divider, it divides the current. You can see this is the whole current for the whole circuit, the current for the whole circuit. And at this point, because the circuit actually is separated into two paths. So each path has their individual current, and the summation of the two currents is equal to the input current. Okay, so this is easy to understand. For example, if you have a river, actually at some point the river is separated into two rivers. That means the total current of the two rivers must be equal to the current of the single river before the single river broken to two rivers, right? So that's reasonable. The same thing for circuit. This we have this relation. This current actually is equal to the summation of these two individual currents. Okay. So this actually is called current division, and for current division, actually, you have to use this formulas to calculate for the current. So I1 will be equal to I. That's the current before the separation. Okay, so it's equal to R1 times R2 over R1 plus R. You see, I1 is equal to R2 over R1 plus R2. Okay, and let me see. I think that's a typo. Okay, let me see. RT. Let me see. RT. Okay, it should be R1, I believe. That's a typo. Okay, so this is a typo. So I1 will be equal to I times R1. R1. This should be R1, not R2. Okay. So let me change it. Okay. This is a picture. I cannot change it, but I will change this in the future. Okay, so this is called current division, and so usually, if you want to make a prototype for your circuit, we use a breadboard. Okay, so this is a picture of breadboard, and I can show you what is a breadboard. Okay. This is a breadboard. You can see. So on the breadboard, you can plug your components. So this is you see this one is a push button that you can push, and you can insert the push button into the breadboard to make it you can do some experiments on that. Okay, and in fact for resistors you can plug into the breadboard to test a circuit. For example, if you have a circuit, you design a circuit, then you can insert all kinds of components into the breadboard to make it work as a prototype. Okay, you can do some experiments on this prototype, and then you can check whether your circuit design is correct or not. Okay, and so on this breadboard, in fact, for a breadboard, you see we have these two lines. So for these two lines, they are used for power. Okay, so that means for all the holes in this line, they are all connected together. Okay, so that means if you plug something here, and you see you have two wires. You have this wire and this wire. Actually, these two wires, they are connected together, because for a breadboard, all these holes, they are connected together. Okay, and this one also, all these holes are connected together. So usually we'll use this row of holes as the positive voltage supply line, and this row of holes, they work as the negative supply hole supply line. Okay, so same thing for the other side. Okay? So if you look at my breadboard, you can see that. Okay, so let me show you. You can see you see there are two rows up here and two rows down here. Okay, so these two rows, these four rows actually, they are same as this four rows. So they are used for usually they are used for power supply. Okay, and for the between, you see we have 5 holes for each column, right? These 5 holes, they are connected to each other. Okay, so that's why if you plug a resistor like this, it's not correct. This is a bad connection, because all these 5 holes, they are connected together. Okay, so that means if you plug a resistor to like this, in fact this resistor is shorted. Okay, because all these 5 holes, they are connected to each other by using with a wire. Okay, the wire is done inside of this breadboard. Okay, so you can see each column you have 5 holes. Okay, so each column, they are connected to each other. Okay, so that means if you want to plug a resistor on the breadboard, you can do like this. Okay, because if you plug a resistor like this, this leg is not connected to this leg. It's not shorted. Okay, so but if you do like this resistor is shorted. Okay, you see, for the prototyping area, each 5 holes, they are connected to each other. Okay? Each 5 holes, they are connected to each other. Okay, so after you understand the connection relationship on a breadboard, you can do your prototype. Okay, so this kind of components is LED. It's so this LED, you can see, you can plug this LED to like this, and because these 2 columns, they are separated, so that you can do this. Okay, you cannot plug components this way. For any components, you cannot plug this way, because this actually, each column of 5 holes, they are connected to each other. Okay, so if you plug components like this, you short you short the components. Okay, and this is a kind of circuit. It's called integrity circuit. Okay, so integrity circuits actually looks like this. So you can see these are some integrity circuits. So this they're packaged in in a single silicon package, and then you can plug this kind of circuit into a breadboard like this. Okay, so you can see, you can plug this onto a breadboard, and you can see, in fact, the breadboard is designed for plugging into the integrity circuits into it, because the distance between these 2 rows actually is specifically designed for for this kind of silicon. I mean this kind of integrity circuits. Okay, so that's why you can plug integrate circuits into a breadboard like this. Okay. So so for our experiments, I will give you each of you one breadboard and a push button and some wires, so you can work on your own prototype. Okay. These are some tools that we can use to create connectors. And we know for Raspberry Pi, we have a GPIO. So the GPIO, actually, you can create custom cables like this. Okay. So to create a custom cable like this, you have to use certain tools to do that. Okay. So that's something that I mean, I know computer science students, you don't supposed to work on this kind of thing, but it's very interesting. In fact, electrical engineering is not far from computer science. Okay? So it's better to have some kind of knowledge like this. Okay? So that way you can have a a broader knowledge, not only focus on your computer science software design or algorithm analysis. You can also understand the works performed by electrical engineers and computer engineers. So you want to learn this kind of knowledge. Okay. All right, so DMM, breadboards, and we already introduced those. Okay. And so breadboard actually is very, very useful for electrical engineers, because a lot of time actually, whenever you have some kind of idea, you want to design a specific circuit, you want to test your circuit, whether your circuit design is correct or not. So to test your circuit, you want to make a prototype. Okay. So to make a prototype, breadboard is a must-have device. So you have to use breadboard, and you plug your components into breadboard to make your circuit, and then you test the circuit. If you find that the prototype works fine, works correct, then you can go ahead, make a PCB board, and then you can solder all the components into the PCB board, and to test further. Okay, so breadboard is the first step you have to use to test your prototype. Okay. For resistance, actually, usually you don't measure the resistance in circuit, because if you measure the resistance in circuits, usually you have a wrong display, because for resistors, if you put the resistors into circuit, actually usually it's affected by other components connect to it. Okay, so that's something that you have to understand. And this is another example of breadboard. So you can see. So if you want to measure the voltage, you can use your DMM. So these are the two wires of the DMM. You put the DMM over the resistor, okay, to measure the voltage. If you want to measure the voltage, okay, and if you want to measure the current, so how can you measure the current? You cannot do like this, okay, because we know for each column, the 5 holes, they are connected to each other. So you have to separate this two. You have to separate this into 2 columns, because that way you can measure the current. Okay, so that's something you want to understand. Okay, and some other example of circuits, voltage regulation. Remember, we have AC circuit, we have AC voltage, we have DC voltage. Okay, so for voltage regulator, actually is used to create a accurate voltage. Okay, for example, for for USB we use 5 volts. Okay, but the input to USB usually is not 5 volts. So how can we make sure that the output is 5 volts? You know, for different kind of inputs. So the inputs may be 10 volts, 12 volts, 7 volts, 8 volts, but the output must be 5 volts. So how can we make sure that? We have to use a voltage regulator. So voltage regulator is like this. It's a 7805. So I can show you what does a voltage regulator looks like. Okay, so this is a, let me see. So you can see a voltage regulator looks like this. So it's a, you see, you have a metal part here, because this kind of components actually is a kind of power components. So for power components, that means you know, usually you have a large power you know, processed by it. So that means this kind of components tends to generate a lot of heat. Okay, so that's why you have to use metal to you know, disseminate to you know, disseminate heat, okay, from these components. Because if you don't do that, extra heat may damage your component. Okay, so that's that's a kind of power component. So this and this is a circuit that we can use to generate 5 volts. So you can see the input voltage is 9 volts, and after the voltage regulator, the output will fix to 5 volts. So this, even though the input voltage can be changed, it changed, for example, change to 10 volts, 12 volts, the output still fixed to 5 volts. That's what we call voltage regulation. And so the voltage regulation is a kind of a component or circuit that we can use to make sure that the output of the circuit fixed to a fixed voltage. Okay. And another component is called diode. And diode actually is a kind of semiconductor component. And in fact, let me just go ahead directly, you know, show you what is the diode. So a diode is, the symbol for a diode is like this, and this is a diode. A diode actually, basically, it only allows the current flow in one direction. Okay, so from this symbol, you can understand the voltage, the current can only flow from this side to that side. The current cannot flow back, okay, because diode actually only allows the current flow in one direction. Okay, so in another direction, in the opposite direction, the diode will block the circuit. Okay, so if the input voltage is a AC voltage, so the output will be like this. You can see here. Okay, so this is the V load. That means it's the voltage over this load. Load is a kind of resistance. Okay, so because of the behavior of this diodes, okay, because diodes only allows current flow from this side to that side. So for AC circuit, for AC signal, in this part, that means the current will flow back. Okay. However, because the diodes actually block that flow back current, so that's why you see 0 here. Okay. So this is the usage for of a diode. A diode can block. A diode only allow current flow in one direction. Okay. So this is called a half wave rectifier. And in fact, why? Think about, did you imagine or try to understand why your voltage on your wall plug is AC voltage, but most of your devices actually you have to use DC voltage to drive most of your devices. So how do you change an AC voltage into DC voltage? Okay, an AC voltage from your wall plug to the DC voltage, required by your devices. All your devices, all your television, TV, your computer, your other devices. Most of these devices, they need, DC voltage. Okay? So how can we convert the AC supply voltage from your wall to DC voltage to drive your devices? Okay, so basically you have to use circuits built with diode to do that. Okay, so you can see the input is an AC signal and the output becomes a half AC signal. Okay, so how can we convert further from this half AC signal into a DC signal? Actually, you have to use another kind of device. It's called capacitor. Okay, so you can see combined with capacitor, a diode and a capacitor, you can see the output voltage becomes a very similar. It's not a real DC voltage, but it's very close to a DC voltage, right? So the input is an AC voltage, but the output becomes we can say it's almost DC voltage. Okay, so that's what we can do by using a diode and capacitor. You can see how important a diode to most of our electrical circuits. Okay. All right. So another kind of diode is called light emitting diode. Okay, the LEDs. So LEDs, they are diode, okay, but they are light emitting diode. And LED, they are polarized. That means they have positive lag and negative lag. Okay, so this actually is a LED. I can show you an LED. Let's see. All right, so this is a LED. Okay, so you can see this is a LED. And for the LED, you see the two leg, there are two legs. You see, this is a LED, and it has two legs. Okay. There is a long leg, and there is a short leg. So the long leg is the positive leg, and the short leg is the negative leg. Okay, so remember, LED, they are polarized. Okay. So that means whenever you use LED to build a circuit, you have to make sure that you use it correctly. Okay. So for LEDs, we can connect an LED into a circuit like this. So whenever you want to make a circuit that you want to use an LED to work as a light, a signal light, for example, you can make a circuit like this. So this is the LED, and this is the resistor. So you have to have a special value for the resistance to make sure that the LED can work. Okay, so usually you don't directly connect the voltage to an LED, because if you do that, you will burn the LED. LED has a limitation of the current supplied to it. You cannot supply current higher than the current expected from by the LED. So usually the LED can only endure a current less than 9 milliamps. Okay, so if your current is greater than 9 milliamps, it will burn this LED. Okay, so that's why you have to use a resistor to to limit the current flow into LED. Okay, so that's something that you have to understand. Okay, so in this example, why we choose 222 ohms for the LED? Let me show you. Okay, so you see. Let me see. All right. So in the circuit, remember we have supply 3.3 volts, and then we have a resistor. We have a I don't know how to. We have a okay. So this is the LED, and this is the resistor. The LED actually it is 1.3. I don't know how to do this. So LED is 1.3 volts, but 9 milliamps. Okay. All right. So in this case, if the VLED is equal to 1.3 volts, then VR is equal to 2 volts, because the total voltage is 3.3, right? So VR, that means the voltage over the resistor, this is VR, okay? So VR is equal to 3.3 minus 2.3, 1.3 is 2 volts, okay? And we know the current is equal to 9 milliamps, okay? So that means the resistance R is equal to, according to Ohm's law, is equal to VR over I, okay? So it's equal to 2 volts over 9 milliamps. Remember, you have to use amps instead of milliamps, okay? So milliamps, 9 milliamps actually is equal to 9 times 10 to the power of -3 amps, okay? So if you do this, actually, it's approximately equal to 220 ohms, okay? So that's the way that you can figure out what is the resistance that you have to use for the resistor, okay? If we go back, you can see that. So it's 220 ohms, right? So that's the way. So in the future, if you want to design your own circuit that you want to use LED to work as a signal light, and you want to create a circuit like this, you can use this method to calculate for the resistance of this resistor. Okay. Okay. So today, let's just stop here. So today I introduced several kind of electrical components, and we also I show you there are several kind of devices that we can use to analyze circuit. Okay, so so that's what we covered today. So for today, I actually I showed you several examples of your not typical electrical components that we can use to create a circuit, and also I showed you several examples that how we can apply Ohm's law to calculate for current, to calculate for voltage, and also resistance. Okay. So like I've said, I'm trying to make a plan to let you come to my lab to pick up the components. Then you can work on the project by yourself back at home. So I will let you know. At this time, I just continue with the lecture. So once I have the plan, I will let you know, and then you can come to the lab to pick up your components, and then you can work on your project. Okay. As we done before, if you haven't typed in your full name into the chat area, please do that. That way I can take the attendance. Okay, so do you have any questions? Do you understand what I'm saying? No questions?
Questions.